In this statistics video, we will be discussing how to do hypothesis testing for proportions. Again, we'll be using the p-value and the critical value method, but we will not be covering confidence intervals for these hypothesis tests. All right, so when you are using technology, when you're doing hypothesis tests, it's really important that you know the number of successes. So even if they give you the sample proportion, like in our last video, we had that survey that had 926 respondents, and they said 52% of them answered yes, but 52% did turn out to be a whole number. It was 481.52, which we had to round up to 482. It's really important that you know the actual number. So if they do give you a percentage, please make sure you find that the actual number X. Very important to make sure that we're getting the most accurate results possible. So again, don't round anything until you round at the very, very end when you're doing your test statistic. So just a caution, again, make sure that you're using that X, which is just n times p hat, and then round it to the nearest whole person. And again, so you may have to round up. So if you get any kind of decimal, round up to the next person. When you're testing these claims about proportions, the confidence interval is not equivalent here. It's not going to give you the same results as a p-value or a critical value method would. So just my recommendation is that just use confidence intervals when you're estimating population proportions. But when you're doing hypothesis testing, please make sure you're using the p-value method or the critical value method to do your hypothesis testing. Just my word of advice. So just to recap, when we're doing a claim for a population proportion, our objective is that we're going to conduct this formal hypothesis test about that proportion. And then we are going to, again, make sure you know all your notation, keep everything correct. And then again, all of our proportions use a z statistic, so make sure that you know how to find that test z statistic for the problem. Reminder that when we are testing about these population proportions, it has to meet all of these requirements. Number one, the observations have to be simple random samples. They have to meet all the conditions for the binomial distribution that we talked about way back in previous lessons. And again, I listed those here. And that, remember, your n times p has to be greater than or equal to 5, and your n times q has to be greater than or equal to 5. So please make sure that you're satisfying all these before you get started. And again, just a reminder, if you're going to use your p-value, here's that flow chart we talked about in the last one. So definitely might need to come back to this later on in the video. So you might want to bookmark this point in the video so you can come back to it. And if you're using critical values, this is again how we're looking for those green rejection zones to reject the null. So you might need to come back and forth to this little point in the video just to see those two things if you haven't printed out the flow charts or the notes for this. All right, so let's just do some examples. I think that's the easiest way to learn these, is just to learn by doing. So let's just do some examples. So we have a study on sleepwalking. Or nocturnal wandering, if you want to be politically correct. Now they call it nocturnal wandering. It was described in Urology magazine and included information that 29.2% of the 19,136 American adults have sleepwalked. Would a reporter be justified in stating that fewer than 30% of adults have sleepwalked? So let's use a significance level of 0.05 to test that claim. For the adult population. Okay, so let's go through all the 8 steps. You may need extra space, so if you'll notice in the notes that I handed out, that I put on my Canvas course, I did include extra space for you to show your work for this problem. All right, so number 1, make sure that you're meeting all the requirements. And that's not something I'm going to ask you to write down, but this is something you should know. So this is a simple random sample? Yes, it is. Is there a fixed number? Yes, there's 19,136 independent trials. The subject was just asked, have they sleepwalked or not? So those are all independent. If we take n times p, is that greater than or equal to 5? And it is. And if we take n times q, is that greater than or equal to 5? It is. So we're good. All of our requirements are met. All right, so now we can start thinking about the 8 steps. Okay, step number 1, what's our original claim? And then put that in symbolic form. All right, so in here in words, this is what they were claiming. Fewer than 30% have sleepwalked. How do I write that? Symbolically. Okay, so that would be P is less than 0.30, right? Fewer than. Step number 2 is to write the opposite of that claim. So the opposite of that claim would be that P is greater than or equal to 0.30. All right, step number 3. Because our original claim doesn't have the equality sign, I know that that is my null hypothesis. So that's my my alternate hypothesis. So my null hypothesis has to be that P is equal to 0.30. Remember, the null is always going to have the equal sign. So this is my claim right here. My claim is going to be the alternate hypothesis. All right, step number 4, what is my significance level? And again, that was given to me in the problem. So there's my alpha. So I'm just going to write that down over here on this side. Alpha equals 0.05. Kind of important. All right. And then step number 5. Right, okay, we are going to use the test statistic. It's going to be a z because it's always z for proportions. That's the nice thing. All right. So you've got a couple of, you could use your, once you've found this test statistic, you can use technology either way. You could even use technology to find the test statistic if you wanted to. I personally like writing everything down. All right, so I'm going to start with my z. So that's going to be p hat, which was, here's your p hat right here, 0.292 minus 0.3, that's our p, divided by the square root of p times q, so that'd be 0.7, all over n. All right, so I put all that in my calculator, and if I round it, I should get negative 2.41. Again, very important that you know how to put everything in your calculator and get this value. So please practice with your calculator. All right, so we're going to do this both ways. We're going to do this with the p-value, and we're also going to do it using the critical values because I want to see both ways. So if I'm doing the p-value, all right, this is one-tailed, right? This is going to be a p is less than, so it's a left tail. Okay, here is our test value, negative 2.41. So if I go on my z-chart and I find out what this area is right here, which is what they give me in the chart, right? Because it always tells me the area to the left of the z-score. So that turns out to be, if I go look at the chart, that should be 0.0080. All right, so that is my p-value right there. So if I take this p-value and I compare it to my alpha, notice that the p-value is smaller, much smaller, right? It's less than 1%, right? So my p-value is much lower, which tells me that I am going to reject the null, right? If the p is low, the null must go. So that means I'm going to reject the null. But the null was not my claim, right? So all I can say is that there is not sufficient evidence to support the claim. Oh, wait a second, back up. Okay, I'm rejecting the null. This means we have support of this. However, we have support for it, but that doesn't mean we can say, yes, it's true. It just means we have support. And having support is, you know, like having $1 million in the bank when you need a glass of water. Okay, the $1 million in the bank is not going to buy you a glass of water if you're in the middle of the desert without, you know, someone to buy it from. So all we can say is that there is sufficient evidence right now to support it. I can't say it's 100% correct. I can't say I accept it. So all I can say is that there is sufficient evidence to support our claim right now that fewer than 30% have sleepwalked. That's all I can say. And again, if you need to refer back to that chart, remember how the flow chart that I showed you in the last video where we talked about, like, if it's left-sided, you go here and then you go down here. And if I'm rejecting the null, this is how I'm going to write it. That's what you need to follow, and just follow that. So again, to word it correctly, there is sufficient evidence to support our claim that fewer than 30% of adults have sleepwalked. Now, if you were going to do this same thing, but you were going to use the critical critical values instead. Okay, so if you're using your critical values, the important thing to remember is that you're going to establish your normal using that alpha of 0.05. Okay, this is a one-sided, which means we're going to be here. We want this alpha to be 0.05, and we want this area to be 0.95. So if we look up on our chart for 0.05, it's going to tell us exactly what that cutoff value should be. And that would give me a z value of negative 1.645. Okay, so this would be our rejection zone. Now, what is my test statistic that I found? I got negative 2.41, which would be over here, right? So negative 2.41 was my test statistic would be right there. I can spell test statistic. Okay, so notice we are in the rejection zone, which means we are going to reject our null. Again, same conclusion, right? We're rejecting the null, which means there is sufficient evidence to support the claim that fewer than 30%, because our claim was the alternate. So we do have sufficient evidence to support it. We can't say we accept it, but we can support it. All right, so we are going to have you do both ways in class. Some classes only use p-values and they use technology to do everything. I prefer to do everything on paper because I really want you to understand and make sure that you know both ways, because sometimes it's just easier to do it one way or the other depending on what information you have. So we're going to do this again, but with a different example. And again, if you'd like to try this on your own, please feel free to press pause and then come back in a little bit. All right, welcome back. So let's see how you did. All right, so we got the Federal Family and Medical Leave Act. In 2000, 60% of respondents to a survey stated that it was easy for them to get time off. Personally, I did not find that. I tried to use it once. It was horrible. My boss was not very nice. So I would be one of those 40% who said that was not easy. Okay, a researcher wishes to see if the percentage of who said it was very easy to get time off has changed since the year 2000. So a sample of 100 people was used, and we talked to them, and 53% of them said they found it easy to use the Family and Medical Leave Act. Okay, at an alpha of 0.01, has this percentage changed? All right, so let's walk through the whole thing. Again, we're going to make sure that we meet all the requirements. Spoiler alert, we do. I'll just tell you right now. Where's our claim? Okay, a researcher wants to see if the percentage has changed. Okay, notice it didn't say bigger or smaller, right? It just said it's changed. So a researcher wishes to see if the people who says it has changed. And this is where a lot of people struggle with this part. So that is my null hypothesis. They want to see if the proportion has changed. Is it no longer equal to 60%? So my null is going to be that the proportion is 60%, 0.60. Right, so there's my null. And again, I'm just going to write claim here just to remind myself that that is my claim. All right, we've got an alpha of 0.01 that was given to us. All right, we need to find this the test statistic. Let's see. And again, this is a proportion, so we're using the z. So p hat, which again, there was our p hat, 0.53 minus our p. All of that divided by the square root of p times q. Again, 1 minus 0.6 is 0.4. That's my q. And then 100 people. I'm going to put all that into my calculator and then round it to 2 decimal places. So you should get negative 1.43. All right, now, if you're doing the p-value method, okay, here is your test statistic, negative 1.43. Okay, because this is a two-sided, whatever this area is, you want to double it. So you're going to take 2 times that area. So I'd go look on my chart, and I would go look at negative 1.43 on my z-chart, my z-score chart, and I would find that that area is 0.0764. I would double that, which would give me a p-value of 0.1528. Okay, notice my p-value is much larger than my alpha. So because my p-value is much larger than my alpha, then I cannot reject. I cannot reject the null. So this, you are not going to reject. So is that going to help my claim? It is totally not. So there is not enough evidence to support the claim that the percentage has changed. Okay, because I can't reject that p equals 60%, unfortunately. So that's how you would do the p-value if you were doing the critical values. So again, that's why I gave you extra space on that paper. So your alpha was 0.01. Okay, so if you were to look at your normal distribution, your 0.01, this is two-sided, right? Two-tailed, which means that this area would be 0.005 and this area over here would be 0.005. So I would go look up on my z-chart and find what would give me an area of 0.005 right here on this end, and that would be negative 2.58. So that means this would be positive 2.58. So these two are my critical areas. Notice my test. What was my test? My test z was negative 1.43, which would be right here. So notice I am not in the rejection zone. So because I'm not in the rejection zone, I do not reject the null. Whoops, reject the null. So because I don't reject the null, that means there is not sufficient evidence to support the claim that the percentage has changed. So notice you get exactly the same conclusion regardless of whether you use the critical value method or whether you use the p-value method. Please make sure you know how to do both because you will expect it to know how to do both on the assessment. All right, so go practice some proportions. Come back next time. We're going to talk about the mean. The mean's a little bit longer because we're going to have times when we have the standard deviation of the population and times we don't. So we're going to have to do two different methods there. You have to use two different distributions, a t distribution or a z. So that lesson will be a little bit longer, but for now, practice these proportions. Come back next time. We'll talk about means. See you then.